Greetings, learners. Welcome to another math session. In this session, we'll be looking at the number pattern. So if we can check on question 3, we are given a question here which involves a linear pattern. So one thing that you need to remember about a linear pattern is that it has a constant first difference. So that's what you need to remember about the linear pattern. So question 3, I will write as Q3 here. So for 3.1, they asked us to determine the general term Tn of the linear pattern, right? So we know that it has what a constant first difference. So our numbers is 5, -5, 0, and then third term is what is 5. So the first term is -5, second term is 0, third term is 5. Okay, and then there are other terms there. So for us to get the constant first difference, we need to minus term 2 from term 1. So, and also here term 3 minus term 2, right? So we'll get our constant first difference. So 0 minus -5, 0 minus -5 is what? Is positive 5. So you need to be careful on this. 0 minus -5 is what? This becomes positive. Then you have 0 plus 5, which is what? Which is 5. So 0 minus -5, it gives us 5. So it's very important to take note of that. So this is 5. And also here, 5 minus 0 is what? Is 5. Right, so this is our first constant difference. So for us to write the general formula, we have Tn equals to An plus B. So in grade 11, this is the formula that we need to use for us to find the general formula of the linear pattern. 5 is our what? It's our constant difference, which is 5n plus b. So Tn, what is our Tn? Tn is our value. So we can choose any value. We can choose the first term, we can choose the second term, we can choose the third term. In this case, we can choose what? We can choose the first term here, right? So we can choose the first term. Okay, so if we choose the first term, our Tn is what? Is -5, right? It's -5. We can see the first term is -5. So the position of the first term is is 1. It's on position 1. This one is on position 2. This one is on position 3. So n is the position. It's on position 1. So our b will be what? Will be -5. Our 5 here, when it goes to the left hand side, it becomes negative, and then we have -5 and then -10. So b will equal to -10. So we can write the final general formula. Our final general formula will be Tn will equal to our a. Remember, our a is 5. So it's 5n minus 10. So this is our general formula. Okay, so 3.2, they asked us to calculate term 12. So for term 12, we just use this general formula, T12, right? In our 12th position, what will be the value of T12? In the place of n, we put 12. So 12 here, then minus 10. So this we can compute using our calculator. Okay, so this will be what? 5 times 12 minus 10. Okay, 50. So it means that the value of T12 will be what? Will be 50. Okay. And then 3.3, they ask us, okay, this was 3.2. So for 3.3, they ask us to what to find which term in the number pattern has the value of 130, right? So 3.3. So want to know the value Tn equals to 130, right? So we know the general formula, which is what Tn equals to 5n plus, sorry, is negative 10. Okay, and then our value of Tn will equal to what? 130. So this will be 135n minus 10. And then we have what? We have 5n equals to this negative 10. When it goes to the left hand side, it will be plus 10. So plus 10, 130 plus 10 is what? Is 140. And then you can simply divide by 5 both sides, such that here they cancel. So our value of n will equal to what? 140 divided by 5. So you can confirm 140 divided by 5. Okay, we get 28. Okay, so it means the value of n is 28, right? So we are done with the first part of this question. Okay, so for the second part of the question here, we have a quadratic formula. As you can see, question 4 here. So question 4, they ask us if this is a quadratic number pattern. So we're given 13, uh, 27, 45, and 67 as number patterns here. So we want to determine whether it's a quadratic number pattern. So a quadratic number pattern differs from a linear pattern in a way this one has a second constant difference, not the first constant difference, but a second constant difference. Okay, so for this one, I can name this one Q4. So 4.1.1. For this one, okay, we have 13, 27, 45, and 67. Okay, so we want to determine whether it's a quadratic. So let's first find the first common difference, the first difference here, which is what? 27 minus 13 is what? Is 14. And then 45 minus 27 is what? Is 18. Okay. And then 67 minus 45, you'll get what? 22. Okay. And then 18 minus 14, you get what? You get 4. And then 22 minus 18, you get 4. So we can see we have a second constant difference, right? A second constant difference. So we can say that this is a quadratic number pattern. Okay, then you state your reason here. So the reason will be what? This pattern has a second constant difference. Okay, there's a second constant difference. So there's a second constant difference. So this is the reason that you state that is a, a quadratic number pattern. Okay, and then moving forward to 4.1.2, we need to determine the general term Tn of the quadratic pattern, this one, right? So in order for us to determine the Tn of the quadratic pattern, we need to use this step, the following step here, but this step doesn't change. So as long as you are dealing with quadratic patterns, you know that you have to use this step. So first thing, as we did here, you find the first difference here, which is what we found is 14, 18, and 22. And then the second difference, which is what 4 here and also 4. So this is very important because this second difference here, you need to equate it to what? You need to equate it to 2a, right? So the second difference here needs to be equated to 2a, okay? And then the second, this one, this is the first difference. Remember, is the first difference. This one, the second difference. This is the first difference. The first difference needs to be equated to 3a plus b, and then this one here has to be equated to a plus b plus c. So the first term here has to be equated to a plus b plus c. First difference 3a plus b, and then second difference is has to be equated to 2a. So we can now solve equating 2a with 4. So when we equate 2a with 4, we can determine the value of a, right? So it means, therefore, our a will equal to 4 divided by 2, which is 2, right? You can see it, if 2a equals to 4, so it means that a will equal to 4 divided by 2, which is 2, okay? And then since we know our a, we can come here, 3a plus b equals to 14 is from here. 3a plus b equals to 14. So we know our a, can just substitute the value of a, which is 2, plus b equals to 14. Therefore, we can see here 2 times 3 is what? Is 6. So 6 to the other side, it will be what? B will equal to 14 minus 6, which is what? Which is 8. So the value of B is 8. Okay. And then now we go to the last one, A plus B plus C equals to 13. Okay. So A plus B plus C equals to 13. So the value of A we know is 2. The value of B, we calculated it as 8. And then C here. Now we can now solve for C. So, okay, it's very important to note here as well. 2 plus 8 is what? Is 10. And then 10 to the other side will be negative 10. So C will equal to what? 13 minus 10, right? So 13 minus 10, which is what? Which is 3. So this means that our general formula for the general term, so it will be, our a is 2, so we have n squared, 2n squared plus B is 8, right? So 8n plus 3. So plus 3. So this is our general formula. This is our general formula. Okay. So we have our general formula as this here, as it was requested here. Okay, so moving forward, so for the next question, they asked us to calculate T100. So 4.1.3, we need to calculate T100. Okay, so we need to go back to our general formula. Okay, our general formula was Tn 2n squared plus 8n plus 3. Okay, so we need to find where T100, what the value of T100 is. So T100, we can see, we just substitute where in the place of n we put 100. So it will be 2 100 here, we square, plus 8 100 plus 3. Okay, so we can compute this using our calculator. So when we use our calculator, 2 times 100 squared plus 8 times 100 plus 3. Okay, so we get 20,803. Okay, so 20,803. So this it will be our value for T100. Okay, so moving forward to 4.1.4. So they tell us that the first difference between the two consecutive terms of a quadratic number pattern is 110. Determine the values of these two terms, right? So from where we solved our, because if we can go back here, our quadratic pattern. So the first difference, right? They say they give us the first difference between two consecutive terms of a quadratic term, number pattern is what is 110. So we look at the first difference. So we look at the pattern here on the first difference. So the first difference we have what, 14, 18, 24. I mean 22, not 24, 22. Okay, so we need to write that pattern here. So which is 14, 18, and 22, right? So we need to find um, where this first difference, the number pattern equals to 110, right? So these are patterns, so we need to find where we'll have 110. So which two consecutive numbers will give us this? So let's first find the formula, the general form, because this one becomes a linear pattern. Now it forms a linear pattern. Why? Because we have a constant difference here of 4 and 4, right? So we use our linear pattern general formula, which is Tn equals to an plus b, right? So we use this formula here. Tn is the value of the number pattern. So 14 is the value, and then 18 is the value. So you can select any value here. So for this one, 14 is our value. We know that A is what is our constant difference here, which is 4. We know this 14 is from the first position, and then we can find B. Okay, so B will be 14 minus 4. Okay, so it will be 14 minus 4, which is what? Which is 10. So it means that our general formula will be Tn equals to 4n plus what? Plus 10. Okay, so it will be uh, Tn equals to 4n plus 10. Okay, so if I can continue on this side here with our general formula that we just calculated, Tn plus, Tn equals to 4n plus 10. Okay, so we need to find where our value is, what is 110. So Tn will have to be equal to 110, and then we have 4n plus 10, and then when we solve for n here, this 10 has to go to the other side, and then we'll have what? 100 will equal to 4n. So the value of n will be what? Will be 25, right? So it means that the two consecutive terms are in term 25, and the next one after 25, it has to be term uh, 26. So these are the two terms. So we can find the values of these two terms. When we find the values of these two terms, we have to substitute to our original equation, this original equation of our quadratic equation, to find the number patterns, right? So we have to substitute on this original equation here. So our original equation is Tn equals to 2n squared plus 8n and then plus 3, right? So to confirm, this is our original equation. So you just need to substitute for the first one, T25, and then we just substitute here. In the place of n, you put 25 squared here, and then 825 times it here, plus 3, then you get your value. And then 26, you do the same, 2 26 squared, and then 825 times it here, plus 3. Sorry, it's not 25, it's 26 here. Sorry about that. So you use your calculator. So for the first one, go to your calculator. Okay. So, okay, just a sec. Try to move this. Okay. So we have what? We have for the 25, we have 2 times 25 squared plus 8 times 25 plus 3. And then you'll have 14, 5, 3. So it means here it's 14, 5, 3. So it means that since we have a difference of 110 here, you can estimate this one has to be what? You can estimate, you just have to add 110 to this one, but we can calculate. You'll see the difference is 110. So going back here, just add, put 26. 26. Yes, now you have 15, 6, 3. 15. So you have 15, 6, 3. So the difference between these two will give you what? Will give you the 110. You can confirm that. and see if you get it. Okay. And then for the last one here, okay, for the last one, we have to show that all the terms of these quadratic number patterns will be odd numbers. So for this, we have to go to our quadratic number pattern, right? We have 2n squared plus 8n plus 3, right? So if you can check the first coefficient here from the n squared here, we can see this is what? This is an even number. So whatever that we substitute, any number that we substitute here, as long as like we're dealing with integers, right? We're dealing with integers because number pattern has to be integers and they have to be positive integers. So we can see here, we'll always have an even number here. So also here, since our coefficient here is even, we'll always have an even number. So when we add an even number and an even number, we'll have an even number. So here we have an odd number. So when we add an odd number to an even number, we'll get an odd number, right? So that's the reason that we give here. So, okay, for the first coefficient, you get is the even number, right? You can see the first coefficient is an even number, and then the second coefficient is what is the even number as well. So the last number in the pattern is odd. Therefore, when we add an even number to an odd number, we always get an odd number, right? So when we add an even number to an odd number, we always get an odd number. So that's the reason, right?